Okay, I went ahead and did this a little bit of a different way. So what we want to do first is list all the things that we want to factor, and there's only 5. And so from there, I wanted to list all the primes of 0th degree. So I went ahead and did that. Well, actually, that's not true. Anyway, I'm going to erase that part. Okay, so I listed all the primes of 1st degree here. And I went ahead and tried to divide these by the 1st degree. Because if it's divisible by a 1st degree, then we can find the 2nd degree that it'll be divisible by. But that 2nd degree, we're not sure if it's prime or composite. So either we could take that second, for example, what happens here, we can see it's divisible by this is divisible by this. But what about this? Then we'd have to divide that a bunch of times over. So instead of going that route, I went ahead and just listed all the composites of 2nd degree. So x plus 1, x plus 1, x1 plus 1, x plus 2, x plus 1, x plus 3, x plus 1, x plus 4, and then x plus 2 multiplied by x plus 2, etc. And these are like all the combinations or permutations or whatever. And I got this list, right? So if it's not in this list, then it shouldn't be, then it should be prime. As long as it's a monic, and meaning it has a 1 in front of the leading term. So it's 1x cubed plus 3x plus 4. It's a monic because right there, that's a 1. As long as it's a monic and it's not obviously, for example, something very simple like x to the 4th. I didn't include that either. Plus 0x to the 3rd plus 0x squared plus 0, because I know that that's divisible by x. So just all the non-obvious ones. And so from there, I went ahead, and if you check out this number, you can see it's not in this list here, so it's a prime. So that's what's one way you can check it. Or you can just keep dividing them. Probably the best way to do is just keep dividing it. And then here, with this one, I noticed it was not divisible by x plus 1, x plus 2, x plus 3, x plus 4. And so from there, you can just say the whole thing is prime. So from here, you can take this, divide it by x plus 2, x plus 3, x plus 4, all those numbers, and you end up with something that's divisible by, the first one I got is x plus 3 right here. But then I forgot to divide it by x plus 3 again once I got to the second one. But then when I tried x plus 4, I realized that there's actually 2 factors of x plus 3. But you could possibly skip over it. For example, let's say you had a x plus 3, something x plus 3, x plus 3. And whatever, let's say you skipped over, you found out it was divisible by x plus 3, and then you didn't know how to figure this one out, and all you did was check x plus 4 from then. You could look here and actually see, oh yeah, I must have made a mistake, because actually it would be right here. So, but again, it's I kind of did it a different way. Probably the most efficient way is just to divide it by x plus 1, x plus 2, x plus 3, x plus 4. And obviously if it's, and then that's it. So yeah, and then again here, let's look at this. I found out that this is a prime because it's not in this list over here again. So x squared plus 3x. So I'm looking here, x squared plus 3x. Okay, this is an x squared plus 3x, but it's not plus 3. X squared plus 3x, but it's not plus 3 again. So we know that that's prime. All right. this is it.